Okay, today we learned lesson 2.10, module 2, lesson 10, and your learning goal is to use what you know about place value, to carry on what you learned last week about area model and standard algorithm to multiply decimals that have tenths. But to help us with today's math lesson, I want us to review the concept of how we can say decimals in different ways, okay? So right up here on the board it says 7.463, right? How would I say that in word form? 7 and 463 thousandths, right? Is that the only way to name the number? What if I wanted to split it here? What number is that? 74 what? Tenths, because that's in the tenths place. And then what is it over here? 63 thousandths. Is that the only way to split the number? No. Could I split it like this? Yes. What number do we have there? 746 hundredths, because now the last digit's in the hundredths, and 3 what's? Thousandths. What if I wanted to put it all into one group? It would be 7,000. Good. So do you see how when you split a number, wherever you split it, you just look at the rightmost digit and then you say that place value? Yeah. Right? So if I had this number, 938. Right now that's 938 what's? Ones, because the rightmost digit is in the ones place. If I put a decimal point here, now it's 938 what's? Tenths. Okay. What if I put the decimal point here? Now it's 938 hundredths, because you can see the decimal place keeps moving. What if I put the decimal point here? 938 thousandths. So for today's math lesson, we really need to remember how we can name numbers in different ways, okay? The directions tell us to first estimate the product. Wait a second. If we know how to find the exact answer, why do we ever need to estimate? Jaden?
To make sure that the answer is reasonable.
To make sure the answer is in the right zone, right? Or that we're in the right area, okay? So first we're going to estimate to solve the product, or estimate the product. Then we're going to solve using an area model and also the standard algorithm. We're going to remember that we always need to express our final answer in standard form, okay? So let's first write down in our notebooks 43 times 2.4. Now when we estimate, we use these wavy lines to show us that we mean that the factors are about these sizes. So 43 is pretty close to what number that's easier to work with? 40. And 2.4 is pretty close to what whole number that's easy to work with? 2. So we estimated the factors. 43 is pretty close to 40, and 2.4 is pretty close to 2. And in our heads, we know that 40 times 2 is 80. So therefore, we know that our answer, our final product, should be pretty close to 80. Okay? Now, the next step says to use an area model. So we know that when we use an area model, we want our, let's put 43 on the side there and 2.4 on the other side, on the top. Now we can think in our heads that 2.4, if I want to rename it only using whole numbers, let's say I want to get rid of the decimal point, 2.4 with just whole numbers would be a 2 and a 4, right? So that would be 24, right? So another way to say 2.4 is 24 what's? Tenths. Okay, so write that in your notebook. Write that you're thinking, write it down that you're writing that 2.4 is the same as 24 tenths. So instead of writing 2.4 on the top here of our area model, could we say that this is 24 tenths? Okay. Now, do you think if I just write 24, that's okay, or do I always need to write the word tenths? Yeah, because if I forget to write it, will I forget that I'm working in tenths? I definitely will. Now let's use what we know about area models. Instead of having 43 here, we could have a 40 and a 3. Okay. And then instead of having 24 here, we could have a 20 and a 4. Right? But we need to remember that these are 20 tenths and 4 tenths. So make sure you write tenths there. Okay? Okay, if I have 40 times 20, I can do 4 times 2, which is 8. And then how many zeros do I have to add? 2. But is it 800 ones or is it 800 tenths? Tenths, very good. So make sure you write the word tenths. If you don't write the word tenths, you'll get it wrong. Okay. Now if I want to find the area of this part, I can do 40 times 4, which is 160. But it's what, everyone? Tenths. Good. So make sure, once again, make sure you write the word tenths. Now to find the area of this section down here, I have 3 times 20, which is 60, but it's tenths. Very good. And then this last one is 3 times 4, which is 12, but it's 12 what?
Tenths.
Good. So this is just like what we did last week, except this time our units at the top is tenths, which makes all the areas tenths. Do you see that?
Yeah.
Very good. Okay, now let's find those partial products. And while we're writing it into partial products, let's also write it into standard form. So if I have 800 tenths, where would I need to put the decimal point to make the rightmost place in the tenths place? Araf?
You have to put it right after this first 0.
Yeah, so 800 tenths is the same as what number?
80.
80. Very good. And then if I have 160 tenths, again, I want that 0 to be in the tenths place, so I'd put it like that. So 160 tenths is the same as what number? 16. So what's that partial product? 80 plus 16 is? 96. Okay. Now, work with your partner to see if you can find the total partial product down here in standard form. Supan, if I have 60 tenths, where do I need to put the decimal point?
In between the 6 and the 0.
Very good. If I have 12 tenths, Mackenzie, where do I need to put the decimal point? Very good. So then that partial product, 6 plus 1.2 is, everyone?
7.2.
7.2. Which one's my correct answer, 96 or 7.2?
None.
Because those are just
Partial product.
partial products. Very good. So then how can I find the entire product?
Add them.
I need to add them up. Go ahead and do it in your notebook. Okay, so then when I add them up, my total product, 96 plus 7.2 is, everyone?
103.2.
103.2. Okay, now is that pretty close to our estimate of 80? Is 103 pretty close to 80? Yeah, it's not too far away. Now let's see how we can use standard algorithm to also solve it. When we use the standard algorithm, instead of thinking it as 2.4 times 43, we can think of it as 24 whats?
Tenths.
Okay, so let's write that. 24 tenths times 43. Now does it become a whole number times a whole number?
Yeah.
Yeah, and do we know how to do that?
Yeah.
Yeah. So our first step, we would do 3 times 4, which is, or 3 times 24. So we do 3 times 4, which is 12. And then 3 times 2, which is 6 plus 1, 72. Did we see a 7.2 earlier? Yeah. Don't add a decimal point yet, okay? Next, we're going to do 4, or is it 4 times 24?
40.
It's 40, so we have to put a 0 there, okay? Now we can do 4 times 4, which is 16. And then 4 times 2, which is 8 plus 1, 9. Okay, so we have 72, and then we have 960. Let's go ahead and add those partial products. When I do that, I get, what do I get? 1,000. 1,032. Okay? But what units are we working on? So that needs to come down here. And if I write 1,032 tenths, is that in standard form?
No.
No. So, if I add a decimal point like that, is that in standard form?
Yeah.
Wait, 103.2 tenths? No, I have to rewrite it. I have to say equals 103.2. Okay, let's start by estimating the factors. Okay, 3.3 is pretty close to what number? 3. And 16 is pretty close to what number?
20.
20. So 3 times 20 is?
60.
60. So our answer should be pretty close to 60. It shouldn't be close to 600 or 6,000 or 6. It should be close to 60. Okay? Now let's think in our head. 3.3. That's the one with the decimal, right? That's the same as what? With just whole numbers.
33 tenths.
33 tenths. So when we do the think part, we just want to get rid of the decimal point and write it as a whole number and then write the units. Okay? Do you guys agree that 3.3 is the same thing as 33 tenths?
Yeah.
Very good. This time, let's do the standard algorithm first, and then we'll do the area model after, okay? So we have 3.3 times 16. Is that the same thing as 33 tenths times 16? Okay, let's think of it like that, because we learned last week how to do whole number, double digit, standard algorithm. So let's keep it like that instead of thinking about a decimal point, okay? So then we have 3 times 6, which is
18.
18. So we'll write the 1, 8, and regroup the 1. And then again, we have 6 times 3, which is 18. And then, but we have to plus 1, which is 19. And then now we're doing 1 times 33. We're doing 10 times 33, so I need to write a 0 there to show I'm working with the tens. 1 times 3 is 3, and then 1 times 3 again is 3. Okay, so those are my partial products, 198 and 330. If I add them up, how many ones do I have altogether? Okay, if I add the tens together, how many tens do I have altogether? 12, so I'll regroup 10 of them. And then how many hundreds do I have altogether? 5. So the answer is 528. But it's 528 whats? Tenths. Okay, so then I write an equal sign to show it in standard form. If I have 528 and I want it to be tenths, I need the 8 to be in the tenths place. So Ananya, where do I need to put the decimal point? I need to put the decimal point between the 2 and the 8. Is 52.8 pretty close to 60? Yeah, so I think that we're on the right track, okay? But we still need to do an area model to be sure. Okay, when I draw an area model, I know that I want my top factor to be the same as my top one in my standard algorithm. So it's 33 tenths, right? So how can I split up 33 tenths to make it easy to do an area model? Rohan? 30 tenths and 3 tenths. Good. Okay. And then what about 16? How can I split up 16 to make it easier? Sanatan? 10 and 6. Now, what is the unit there? It's 10 whats? 10 ones. But we don't need to write the ones. If we don't write any units, we assume it's ones. Okay? So if I have 10 times 30, I can do 1 times 3, which is 3. And then I add 2 zeros, right? But I need to remember that it's 300 tenths. Good. Okay, and then I have 10 times 3, which is 30, but it's 30 tenths. Good. Over here I have 6 times 30, so that's 180 tenths. And then I have 6 times 3, which is just 18 tenths, right? Okay, let's add up our partial products. If I have 300 plus 30, what do I have? 330, but it's 330 tenths. And then down here, if I have 180 plus 18, I have 198, right? But it's 198 tenths. So let's write both of those into standard form. 330 tenths is what number? 33. And then 198 tenths is 19.8. So if I add those together, I get 52.8. Did I get the same answer? Very good. Is that still close to 60?
Yes.
Yeah, so our estimate helps us know that we are right. It says Michelle multiplied 3.4 times 52. She incorrectly wrote 1,768 as her product. That's not right. Okay? In fact, I can prove to you that it's not right because 3.4 times 52 is pretty close to 3 times 50. Would you guys agree?
Yeah.
Which should be 150, right? So that means her product should be pretty close to 150, but she got 1,768. So is that right? It's not even right. And this is why it's so important to estimate because it shows you when your answer is completely wrong. But I will tell you something. 34 times 52 equals 1,768. So she did something right. She actually multiplied her numbers right. But what did she do wrong? Talk to your table group. Michelle forgot that she changed 3.4 to 34, right? Was that right to do that? Yeah. Except she forgot that it's 34 whats. Tenths. So here she forgot to write the word tenths, which means she also forgot to write the word tenths in her product. So what should the correct answer be? If it's 1,768 tenths, what is the correct answer in standard form? Gia?
176.8.
Very good. Okay. Now, is that a lot?